Hello, in this video we are going to talk about a technology called WebSockets. What you are already very well acquainted with is the normal HTTP protocol, where what happens is that you have a server, right, and you have a client, and what we have learned so far is that the client sends a request, okay, and it gets back a response. And one thing we know that the server cannot initiate communication on its own, okay. The client always has to initiate the communication and then it gets back the response, okay, because the server does not know about the client in the beginning. Client knows about server has a domain and IP address and so on, okay. Now even in this one request there are a lot of things happening behind the scenes, okay, because you know about like all the networking layers. This request is not just a single piece of request. What will really happen is that you would have say a domain name something like cb.lk, okay. If you go to this place, it basically redirects you to say codingblocks.com, okay, and that actually points to some IP address via the DNS. It probably points to say 12.10. Say 11.5 or something like that, okay. This is actually an IP address, and that actually is the address of the hardware where it is. This address you cannot reach directly from the client because it's not in the same network, because it's on the internet. So what will actually happen is that this is the internet and there are going to be a lot of nodes on the internet, and your request needs to first find a particular path through which it can travel to the server, okay. So it could be this path, or it could be say this path, or it could be this path, okay. You don't know which path it will take. So the client will first find out the IP address of the server, then it will find out a path, how to go there, and then the third step would be that it will first ask the server, are you ready to accept my request? And the server will tell that yeah, I'm good to go. Then it will actually send the request, and upon that the server sends a response. Now the interesting thing that happens here is that once this response has been sent, after that this entire stack is like gone. This entire process of finding out the correct path and sending the request, getting the response back, after all that happens, entire thing goes away. And if you have to send a new request, then this entire thing happens again. You will do this part also again, okay, and it will then again find out the proper path to go. That also it will do again, and then the request is sent and the response goes back. I mean, this kind of a setup, there are a couple of problems out here, okay. So it is first of all very slow. It is slow because this process has to happen, and then this pathfinding process has to happen. Then it has to ask the server whether it wants to take the request or not. This is the standard TCP/IP procedure. So which means that all of the meta activities that happen before the actual request body is sent, that has to happen time and again. So some packets are going to go to and fro from the client before the actual request response happens. And the second thing is that the server cannot send data to the client on its own. The client always has to ask data from the server. But we have requirements. For example, you want to make a chat app, and in a chat kind of an application, what happens is that say there is a client, say there is a server, and there are two clients connected to it, okay. And so when this person sends a message, it goes to the server, and the server should be able to immediately send the message to the client. And like you see in modern chat apps, what happens is that even if this client is say typing on his keyboard, okay, so even when this user is typing on his keyboard, this client gets this three dot which dances around, as you know, a messenger app or something like that, okay. Some typing indication that needs to go, and when this user reads that message, some information goes to the server, and the server immediately gives those two blue ticks to you, okay. These kind of communication has the hallmark of being very fast. And secondly, there needs to be a process via which the server can initiate communication and send it to the client. Now these things are made possible via WebSockets. So what does WebSockets really help you do? WebSockets is basically technology that has a protocol that is slightly different from the way your normal request response thing happens in HTTP. But WebSockets can run over HTTP. It means that if you have a web server and you have HTTP web server running on port 80 on a server, on that same port, on that same server, you can also set up WebSockets. Browsers support WebSockets okay, via JavaScript implementations. There's the WebSocket API in the browsers. What is going to happen is that say there is a server now, and the first thing that we do as a client is that we send a request to some, say, abc.com website, and in the response we get back a web page, and we open this nice little web page. There's some buttons out here, something. Okay, so we have this a web page that has opened for us. Now once this web page is opened, there would be some JavaScript code here on our web page that will ask the server to create a socket connection, and if the server accepts a socket connection, what will happen is, in this case, something like a pipeline will be created between the two of them. Okay, it's a pipeline, and this pipeline is slightly different from HTTP in the sense that first it finds out a particular path via which this connection can be created. Once the path is created and this pipeline has been made, the pipeline is not destroyed until and unless either the client is destroyed, which means the user navigates to some other website or closes his browser, or the server is destroyed, which means that whether the server has restarted or the server crashes or something like that. Unless either of these two sides destroy themselves, the pipeline is created and the pipeline remains established. So which means that every time you want to make some communication from one end of the pipeline to another end, you don't need to find out the IP address from the domain name. You don't need to find out a path. You don't need to ask the server whether it is accepting connections or not. All of that stuff is already done. The pipeline exists. So the the data is going to directly go before all of these meta activities happening. So that makes it fast. The second thing that happens is that both ends of the pipeline can send data from one end to another. So B can send some data into the pipeline and A will immediately receive it. A can also send some data into the pipeline and B can immediately receive it. Okay, which means that it is not a request response kind of a system where responses come only when a request has been sent. The server can initiate communication into the pipeline and the client will get it, and the client can also initiate communication into the pipeline and they will get it. We obviously do not have a mechanism directly to acknowledge whether the server gets the data or the client gets the data or not. What we can obviously do is when B sends some data to A, then A will take this data, it will do something with that, and it will send that acknowledgement back to B via the same pipeline. Okay, so what we are going to use to implement this thing here is a library called socket.io. Okay, socket.io is a famous Node.js library, and now it has been ported to many other languages also. So what socket.io helps us is build this kind of a pipeline, and it has some methods which go by the name. So for example, there is person A and person B on two sides of the pipeline. Either A is server or B is client, or B is server, A is client, does not matter, because in WebSockets you can initiate communication from both the sides. So A can send data into this pipeline using the emit function. Okay, and B will get this data inside the on body of the on function. Okay, this emit data, whatever was sent here. Similarly, B can also send data into the pipeline using the emit function on B side. Okay, and that data would be available to A in the on function of the A side. Okay, that's the basic idea of how the socket API works. The on words, as you can see, it's the event listener API that exists in JavaScript. So these are events that will happen. Okay, so it's like an event emitter, one end of which is running in A and another end running on B. So if you create an event inside A, that event is available on B. If you create an event in B, it is available in A, and you can send any amount of data you want over that. Okay, So we will now get down to our code and see how it is implemented. Okay. So we will start off by creating a run-of-the-mill Express project that we all have seen how it is created. Simple web app which has a very nominal backend and a very nominal front end. So I'll start off with an npm init command to create my package here. Okay, and let's call it socket example and version 1 default stuff. Okay, and I will install the basic packages that I will need here is that npm install express and socket.io. Okay, so .io is the part of the name of the package. Okay, dot is allowed in npm package names. So this package is actually, you can check, it's available on this website socket.io. It's a website on socket.io. You can find all the documentation how to use it. There is a getting started page on how to create a simple chat app, which is the one we are actually creating right now. Okay, and it shows you how to create a simple chat app where people can chat with each other. So we'll just go through all the uh, you know um, steps one by one on how that is created. So what I'm going to do here is I will create a folder called frontend. Okay, and we'll have a file called server.js. So we will have index.html and script.js. In our front end. Okay, and we will add a server.js here. So this is my server code. Okay, um, so our default web server, what it looks like is const express equal to require express, and then so there we go. Basic app has been set up. Okay, and next thing we'll do is add the front end to be available via our express app. So we'll make our front end available, and then we'll add some basic stuff inside our index.html and script.js. So what we'll do with our index.html is standard HTML5 stuff here. Okay, and we'll add a heading, say here, socket.io example, right? And we'll include our script here. We'll do is we will include so my script.js belongs to my front end. Okay, as you can see, it's inside the front end folder here, script.js. Inside my script, let me just write console.log hello on front end. Okay, and so let's just start this project. Okay, so we will go and run our server. Okay, so our server has run and our website is available on localhost 2345. Just click there and it will take us to our website. So let's just go there. Localhost 2345. Okay, so it says socket.io example, and in the console it's gonna say you know hello on the front end. That's what our script says, right? So the website basic stuff is working. Now we'll start integrating the socket.io part here, right? So let's just stop the task first here. So we will require socket.io equal to require socket.io, right? Now here is something interesting that we want. We don't want our app itself to run, but we want to create an HTTP server using this Express app, and then run both our Express app and our socket.io both on the same HTTP server. Now the way to do it is we need to get access of this HTTP module first. HTTP is a default node module available, native node module available with Node.js installation. You don't need to install this package. Okay, HTTP is already available, as you can see. Okay, and then what we will also do is we will instead of making app.listen, what we'll do is we'll create a server first. We'll do const server equal to http dot create server, and inside http dot create server we will add this app object. Okay, so an app is an Express app is also like a middleware which takes a request and sends a response. Okay, so using such an object we can create an HTTP server, and then instead of doing app.listen we will do server.listen. Okay, now app.listen internally does the same thing. It creates an HTTP server and makes it listen. So we do server.listen here, right? And then what we need to do is we need to create a socket.io connection. So for that we will do const io. Io is our socket.io server. Io is equal to socket.io, and we will call socket.io with this server. Okay, so when we run this io equal to socket.io server, what we do is we create a socket.io instance running on this HTTP server, and once our server starts listening here, what happens here is that we go to our website on localhost 2345, and we check out this path /socket.io/socket.io.js. You see this JS file. Now look at this path closely, /socket.io/socket.io.js. Such a path was not available in my app. I have never made anything like this. I have only made my front-end folder available as a static folder out here. Okay, so how is this particular file being available? That's available because the socket.io server-side library, it also makes its own client-side library available as a middleware to the client here. Okay, so this library is the client-side library. How to use this client-side library? We are going to require that from our index.html. In our index.html, what we'll do is we will do script src, and the path is /socket.io/socket.io.js. Okay, cool. So our this is basically our client-side library, and our server-side library is obviously available via require socket.io that we have done in our Node.js code. Now how to use our client-side library is we have once we do this, so let's just rerun this. So just let's run this code again once. Okay, let's run our server. Okay, so with our server running now, if we go to our main page where this script has been included. Now if you go to our console and look for a variable called IO, you'll see that there is a function IO available. And how is this function IO available? It is available because we included this script, and this script makes a global IO function available to us. Okay, what we are going to do now is use this IO object, let socket equal to IO, and we call it. Okay, so generally when we call IO, we can specify the server to which it wants to connect. Okay, we can specify, say, WebSockets / localhost 2345 like this. But if we are connecting to the same server from which our web page has been served, we can leave it empty and it will by default connect to the same server from where the website has been served. Okay, and in our server we now need to listen for when a connection has been created. Okay, that is done via this. So there is a event inside the connection that's available like this, IO dot on. Now I'm going to listen for this event called connection. When the connection happens, we find an object called socket in a function. Okay, and here we can maybe write this thing, console.log new socket formed from, and plus each socket has an ID. Okay, so a new connection has been formed from this particular socket ID. Okay, and on our front end also we can write the same thing. We can say that console.log socket formed on plus socket.id. Okay, we don't need this log line anymore. There we go, correct. Let's run this again. So here our server is running, and once you go to the site, we see this thing, new socket formed on new socket formed from this particular socket ID. Okay, and we get this socket.id print here. It's the same socket that has been created. Okay, now here immediately after writing this line, the socket does not get formed, so we should do something like this here also. We should do socket.on connection. I think just there's going to be no data here, and let's just try this out. We need to send an event from the server. I'm sorry, we need to do something like this. When the socket has been connected, we will emit a signal to this particular socket, socket dot emit connected. Okay, and here we'll get this value here. So we'll just restart our app once again. Okay, so you see the socket has been connected. If I refresh the page again, see again socket has been connected. Let's write down which socket ID is connected. Connected plus socket.id. Okay, then let's refresh the page. So it just connected this particular socket ID, and on our socket side also the same socket ID. Okay, now what happens if I open another tab on the same URL and go to our console? Okay, and you see it's connected to some other ID now, and that same ID is available here. Let's do something. Let's clear this output. Okay, and let's refresh this page. So I'm connected to this ID right now on this tab. Okay, and on this tab, let's so go here and we see that MVP has been connected. Now let's refresh this page, and we are connected on this particular socket ID, and we see that this socket has been connected. So there are two clients connected to our server, because the two tabs are separate clients as far as the server is concerned. They do not know that both the tabs have been opened on the same laptop on the same browser. The server does not know about that. Okay, now let me just go back to the whiteboard and show you what this actually means, having these two socket connections open. Okay, so what happens is you have your server. Okay, and this is your server, and at a time a lot of websites could be accessing this server, and there could be a client 1, and there could be a client 2, and there could be many more clients like that. Okay, so this server has this interface through which socket connections happen, and this is called basically IO. This object is called IO. Okay, now what happens is whenever the IO function is called by a client, whenever we call this IO function on the client, it creates a socket connection from itself to the server. Similarly, when I call the IO function here, okay, it creates a socket connection like this. Okay, and this function returns an object called socket, right? This socket is basically this pipeline. Similarly, this IO also returns a socket object. So this socket is basically this pipeline. Okay, so this entire thing is happening on this client, and this entire thing is happening on this client. Now from the server side, what happens is, as you have seen, I have written a function somewhat like this. I written IO dot on this event connected. So on this, what we have done is we have created a separate anonymous function which has a socket object. Right, so what happens is this is what happens. Just go back. Every time this connection happens, So first this connection, the first connection, say this one happens first, and this function, a copy of this anonymous function is made, function, or maybe using the arrow function that we have done in our code, this function runs socket. Okay, then when the second connection happens, again a copy of this anonymous function is made and it is run. Okay, so now these two have their own closures and they are very separate functions. Okay, so this function has its own closure and this socket basically refers to this pipeline. Okay, and similarly another closure here where this socket refers to this pipeline. So from the server side, the same socket object refers to the pipeline, okay, which from the client side is also referred to by the socket object. Okay, on the server side, the code of this function is actually the same, but a separate instance gets created each time a new socket is made. Okay, we'll be able to understand this a little better when we get down to a little more coding. Okay, so what I've done here is I have downloaded jQuery 3.2.1 and included that in my front end, and I will create a button here. I'll first create a div here and id equal to or what I'll do is I will do something else. I will create an ordered list here. Okay, and I will give it an id equal to message list. Okay, and I'll go to front end code and I will do is first of all create jQuery objects. Out of that I'll create the window load function. Okay, and inside this function I'll do is let message list equal to right, and after that what I'm gonna do is I will create a little text box here. I will create an input type text with id equal to message box, and then I will create a button with id equal to send message, and I will write send inside this button, right? So I will get access to all of these things here. So what I'm gonna do is when the send button is clicked, I am gonna get the message from the message box and then I will emit it into the socket. I will do socket.emit, and in socket.emit I will create a event with the name send underscore message, and here I will send a data which is going to be this JSON object which has message equal to message. Okay, this is the key and the value is actually coming from this object. Okay, or I mean, to make it a little more clear, message equal to just remove this line here. Okay, so that's, I emit this into the socket. Where is this socket available? Here in my server side code it is available as this socket object. So this closure, this function, so a copy of this and body of code runs for each socket. Okay, this body of code is copied for each socket created and it runs. So if three sockets, three clients connect to the server, So 3 copies of this code is made and 3 copies of it is running on the server, because this anonymous function. Okay, there are 3 different closures. So whatever code I write here is going to be executed for all these 3 sockets. Okay, so I will create a listener on this socket. I will do socket.on, and when there is this send message thing happening, what I'm going to get is this data in my callback function. Okay, and when I get this data, I'm going to write here console.log received message equal to data.message, right? And this is the log that I will print out here, right? And so let's let's just stop the server, and let's just run this server all over again. And I have some problem here now. So server, there we go. So my server has started, and let me just refresh this page. Okay, so once this page is refreshed, let me just write, say, ABCD and press the send button here. What happens here is in this code, so nothing has happened. Let's see why. Yeah, so we have received this message on our server. Okay, then on the other app, let's write something like this, maybe say QWERTY, and press send from the second tab, and we will find that we received that message also here, right? What we'll do now is, so you see that we have received this message also. So let us now do is, let us take this message and let us send this message back to all the connected clients. What I want to do here is, when we receive this message, so let's just not log this. Instead, let's do is we do io dot emit receive message and just send this data back, the data that we had received. Okay, what we do io.emit, what happens is that if we look at this diagram, so we do socket.emit from this end, right? What we did is we did maybe use a color, something like use, say, okay. Let's use this color. So when we did socket.emit here, we sent some data into this, okay, from the client side. Okay, and we received that in the socket.on function inside the body here when this message came out of the client from this pipeline out here. So we take this data, okay, and we put that data back into IO. So when we put it into IO, what happens is that it is distributed to all the clients that are connected. Okay, it's distributed everywhere when we do io.emit. Okay, which means that it will be distributed into this pipeline as well, and it should be available to this client and also to this client itself as well. Okay, so on both these clients I will add a listener to get the data back from the server. Let's see how that part is done. On the client side of the code, we'll write a function like this. After our window has loaded, we will add this listener. We will do is when we get socket.on, when we listen for receive message, we will get the data, and once we get the data, what we intend to do is let's just use a JavaScript 5 function, because browsers should not all support ES6 and all everything yet. So just write older version JavaScript on the client side of the code. So on receive message, what we can do is we'll take a message list dot append it with this new element called li, Okay, data dot message, right? And let's just run this server again. Server, so the server running, so we need to refresh the page, we need to refresh this page. So we send abcd, and we see abcd printed back in our client and also on this client. And we send qert from here, we'll see qert getting printed on both the tabs here. So it's running a little bit slow. Let's do is run it from the terminal. I think it's a little slow if we run it like this. So I'll just run it using node server.js. Okay, so there you go. So we send this thing, we send something like this. So as you can see that whatever we type from each of the tabs, it's going to be reflected. And I can even run one from a say private browsing tab, and go to this place and write something, send it, and then this data would be available to the other tabs as well. Okay, so I can write something else. Okay, so as you can see that we are getting real-time communication. So data is actually going from one client, so it's going to round trip, it's going like this, it's going from the client to the server, and then the server is looping it back into both of them, or 3 or 4, as many clients as there are. So this is like a basic implementation of how chat works, and next we will be seeing how to send the name of the sender, or send a read receipt from one to another. Okay.